Hi class, back again today to talk about chapter 7 being about movement. So we'll get started right now. I know you want me to say it. Without further ado, here is the lecture. Let's see, get me up there. Okay. Come on, computer. Okay, well today, as I mentioned, we're talking about movement chapter 7. We're going to start with discussing types of muscles and muscle fibers. Then we'll talk about proprioception today. So first, discussing types of muscles and muscle fibers. If you look at muscles, muscles only work because they're connected to nerves. So the nerves have to make them work, and those are the nerves of the peripheral nervous system, which we've talked about. So there's what's called a neuromuscular junction, which is just what it says it is. It's a junction between the nerve and the muscle. And so it's where those neurons attach to the muscles. And on the skeletal muscles, that's all accomplished by the release of acetylcholine from those nerves. And when you release acetylcholine onto the muscle has receptors that make the muscle contract. So the muscle kind of pulls together and contracts. There is a disease called myasthenia gravis, and that is where you see death of the ACH receptors at the neuromuscular junctions. And that, of course, will cause the muscles not to work in the periphery. And so that is a movement disorder. Well, one thing about muscles is they only contract in one direction. They contract or they relax, and that's it. So there's no way to move a single muscle in two different directions. So what we have are antagonistic muscles, which are pairs of opposite muscles all over the body that move in opposite directions. So for example, you have the bicep that allows you to make a fist and pull up your arm. And then you have the tricep in the back that allows you to extend your arm, similar to the quads and the hamstrings and the legs. Those are the antagonistic pair that allows you to move in two different ways. So there are different kinds of muscle fibers, some that act very fast, and some that act a little bit slower. So we have fast twitch muscles, and this is exemplified in the chicken. When you eat white meat chicken, those are fast twitch muscles. Those are from the breast, and so they're used for flying, or they were when the chicken could fly. Chickens have been bred out of flying for a long time. So it causes a very fast contraction, and it's for very strenuous, fast movements like these runners, for example. It works anaerobically without oxygen. Instead, it uses stored energy or glycogen for movement. And they fatigue really quickly. So you can't do this kind of fast movement for very long. So that's why sprinters sprint for shorter periods of time. The slow twitch muscles are exemplified in dark meat chicken. And you can see that in the legs and in the wings. Those are the slower contraction muscles, and they're really for long-term use, like maintaining posture. So we're using muscles all the time to do that. Those work aerobically, so they do use oxygen while the muscle is active. Okay, so we're going to discuss proprioception next. Proprioception is sensory information coming into the brain about the body. And this will just give you an idea of what movement involves. We have visual input to the dorsal stream to locate a target. So let's say you're going to pick up a cup. You're going to get visual input on where that cup is located, right? The cup is over there. We're going to try to pick it up that way. Then your frontal lobe motor area will plan and command the reach, and we're going to talk about that. And that's that strip of the motor cortex in the frontal lobe, or what we also call the precentral gyrus. The basal ganglia will help initiate that movement, as it does for kind of complicated movements. The spinal cord carries motor efferents. So motor efferents are now going to come down to the arm to reach out. Motor neurons are going to carry signals from the spinal cord to the hand then. And then sensory afferents. Now, as soon as I touch the cup, sensory afferents are telling me about my hand position, about how the cup feels. Is it hot or is it cold or whatever. And then the somatosensory cortex is going to receive those afferents that the cup has been grasped, that the cup is not hot, that you can hold it. And then your cerebellum all throughout is going to be correcting any errors to kind of make things smoother in terms of making that movement a little bit more, what do I want to say, graceful. Okay. So proprioception is just these sensory afferents that keep track of the body as we move around. And so this is sensory information coming in. Remember, afferents are coming into the brain. So sensory information, as it turns out, is crucial for coordinating movement. And we learned that from the deafferentated monkey in the last chapter. The monkey that doesn't have any afferents just stops moving altogether. So there are a couple of really important sensory afferents. One is called a muscle signal, and that signals the stretch of the muscle to the spinal cord. And what it does is cause a reflexive contraction of the muscle, and that's called the stretch reflex. And so the reflex sometimes is tested with a knee tap, but basically if you stretch your muscle out too much, it starts to contract, and it kind of keeps you from overstretching. And so that muscle stretching out will tend to contract. The Golgi tendon organ will signal too much contraction, so it's kind of the opposite. Rather than too much stretch of a muscle, it's too much contraction of a muscle. And that's like if you're lifting very, very heavy weights, let's say, there becomes a threat to the tendon because on either side of the muscle, you're getting a connection to the bone, and it's the tendon that connects it to the bone. And if you contract it too much, it's going to tend to stretch that tendon. And so because there's a threat to the tendon, we have this automatic tendency to drop. And that's what the Golgi tendon organ does, is it causes you to then drop that weight. Okay, we'll do objective number 3 next time. Have a great day.